Hello, this is Sujit. Welcome to Physics 2020. So it is another new start of Physics 2020. In this section, I am going to solve the 33 years of previous year Neet questions. Okay, Neet questions in the chapter that is motion in a straight line. So in Physics 2020, we have completed the chapter that is NCERT third chapter, that is motion in a straight line. With a lot of conceptual sections and a lot of problem solving sections. Okay, so now in Physics 2020 the classes are going on in the chapter that is motion in a plane. So in India the Neet exam, that is National Eligibility cum entrance test for the admission of that is medicine. So before that Neet exam, this Neet exam was introduced in the year that is 2013. So before that we had an exam named AIPMT, that is All India Pre-Medical Test. So based on that exam only the medical admissions are done. So totally the questions in AIPMT as well as in Neet, we have 33 years of questions, and nearly from these 33 years of questions you can expect 60 questions from this chapter, that is motion in a straight line. So you may ask one question, what is the need of solving the previous year questions? It is just like self-evaluation. So after completing or after discussing a variety of conceptual sections and problem solving sections, you should go through the previous year questions. Then only you can evaluate yourself. You can measure the depth of your subject or concepts, whether you are able to solve the questions, okay, previous year questions, and you are ready for appearing the competitive examinations. So that is the main motto of solving the previous year questions. So once again I wish you all the best to all the aspirants of Neet across India. Okay, we start with. A car is moving along a straight road with a uniform acceleration. It passes through 2 points P and Q separated by a distance with velocity 30 km per hour and 40 km per hour respectively. The velocity of the car midway between P and Q is. So these are the four options given for this question. A 33.3 km per hour, 20 root 2 km per hour, and C 25 root 2 km per hour, and D 35 km per hour. So what is given in the question? So this is the visualization of the question. A car is moving along the straight line, okay, straight line with the uniform acceleration, okay. So it moves with it moves through 2 points P and Q with velocity 30 km per hour and 40 km per hour respectively. Okay, so the distance between these 2 points P and Q I am taking as 2D. Okay, 2D. So we have to find the velocity of the car midpoint. So in the midpoint we have to find out. Okay, so total distance between these 2 points P and Q is 2D, is then the distance between P and M is D, and M and Q is D. Okay, so solution. I am considering the motion of the car from P to M. Okay, P to M. I am using the kinematic equation, that is V square minus U square is equal to 2AS. Okay, V square minus U square is equal to 2AS. So V is the final velocity at the point M, okay, point M. U is the initial velocity of the car at the point P. A is the acceleration, and S is the distance between the points P and M. So V square, okay, V square minus, what is U square? That is 30 square, that is 900, is equal to 2 into A Yes, what is yes? The distance between P and PM is, that is D. Okay, D. So take it as equation number 1. Okay. So next I am considering the motion of the car from M to Q. M to Q. Okay, I am using the same equation, that is V square minus U square is equal to 2, that is 2AS. Okay, what is V square? That is the final velocity at the point Q, that is 40 square, that is 1600, minus U square. What is the initial velocity at the point M? Okay, so the final velocity, that is the from P to M, what the velocity occurred in attained this point, that is M, that is V. That is the initial velocity for M to Q. So that is V square. Okay, V square is equal to 2AD. That is the distance between M and Q is D. Okay, take it as equation number 2. Okay, equation number 2. So 1 divided by, equation number 1 divided by 2. So implies, so V square minus 900 divided by, so 1600 minus V square. Okay, V square is equal to that is right hand side 2AD divided by 2AD, because it moves with the uniform acceleration. Okay, acceleration. So this 2AD cancel, that is 1. So cross multiply, V square minus 900 is equal to 1600 minus V square. Okay, V square. So bring this minus V square this side. So 2V square is equal to 1600 plus minus 900 plus 900. So that's equal to 1600 plus 900, that is 2500. Okay, 2V square. So therefore V square is equal to 2500, that is 1250. Okay, 1250. Okay, so V is equal to square root of 1250. Okay, 1250. So I can write that's equal to square root of 1250, that is 625 into 2. Okay, 625 into 2. So that's equal to what is root of 625? That is 25. So 25 into root 2. That is the answer. So the option A, that is 33.3 kilometer per hour. Option B 20 root 2. Option C 25 root 2. So 25 root 2. So that is the answer. Okay. So the second question, a car covers the first half of the distance between two places at 40 km per hour and another half at 60 km per hour. The average speed of the car is. So these are the four options given for this question. A 40 km per hour, B 48 km per hour, C 50 km per hour and D 60 km per hour. So a car moves in a straight line. Okay, straight line. So the first half of the distance between 2 points P and Q, the first half of the distance. So the total distance I am taking as 2D. Okay, 2D. So the first half of the distance, that is D with the speed 40 km per hour, and the second half of the distance, that is also D, 60 km per hour. Okay, so we have to find the average speed. Okay, average speed we have to calculate. So average speed, what is the formula? So that's equal to total distance divided by total time. Okay, total distance by total time. So what is the total distance traveled? That is 2D What is the total time? So the first half of the distance it takes t1 time, and the second half of the distance it takes t2 time. So t1 plus t2. Okay, t2. So what is t1? So speed is equal to distance by time. So from this relation, time is equal to distance by speed. So t1 is equal to, what is the distance? That is d by 40. So similarly t2 is equal to, what is the distance? That is d divided by, what is the speed? That is 60. Okay, 60. So t1 plus t2 is equal to d by 40 plus d by 60. So what is the LCM? So 120 is the LCM. Okay, 120. So 120 upon, so 4 3 times, that is 3d plus 2 times, that is 2d. So 3d plus 2d, that is 5d divided by 120. Okay, 120. So substitute on this formula, that is VAB is equal to total distance, that is 2d divided by total time. So 5d by 120. So that's equal to 2d into 120 by 5d. Okay, so dd get cancelled. 2 times 2, that is 4 times. So that's equal to 48 kilometer per hour is the answer. 48 kilometer per hour. So option B, that is 48 kilometer per hour. So this is the answer. So another shortcut for this question, that is if a car, vehicle or object moves half of the distance and another half of the distance. So if the two part of the distance is same, so immediately we can for average speed or average velocity, we can apply the formula, that is 2 v1 v2 divided by v1 plus v2. This formula we can apply. So instead of doing all these things, we can apply this formula. So that's equal to 2 into, what is v1 first speed, that is 40. What is second speed? That is 60. So v1 plus v2, that is 100. So 0 0 cancel, 0 0 cancel. 6 4s are 24. 24 into 2, that's equal to 48 kilometer per hour. Okay, so the first half of the distance and the second half of the distance. If the two parts of the distance are same, we can apply this formula for both average velocity and average speed. So similarly, if an object moves from P to Q and returns back to P, with the object moves with from P to Q with one speed and returns back to that is Q, from Q to P with another speed. In that case also, for average speed we can apply this formula, that is 2 v1 v2 divided by v1 plus v2. But average velocity in that case, from P to Q and Q to P, what is the average velocity? Average velocity is equal to 0 because displacement is equal to 0. So average velocity is equal to 0. Okay, clear? Third question, a bus traveling the first 1/3 distance at a speed of 10 km per hour, the next 1/3 at 20 km per hour and last 1/3 at 60 km per hour. The average speed of the bus is. So these are the 4 options given for this question. Okay. So 9 km per hour, B 16 km per hour, C 18 km per hour and D 48 km per hour. So a bus is traveling in a straight line between 2 points. Okay, 2 points. So I am taking the total distance between P and Q is 3D. So first 1/3 of the distance it is moves with 10 km per hour. The second 1/3 of the distance with 20 km per hour and the third 1/3 of the distance is moving with 60 km per hour. So we have to find the average velocity. Okay, suppose it takes the time t1 for this part and t2 is the time for second 1/3 and t3 is the distance for time for third. Okay, third part. So VAV is equal to, what is the formula? That is total distance divided by total time. Okay, total time. So what is the total distance? That is 3D divided by total time, that is T1 plus T2 plus T3. Okay, so that's equal to what is T1? T1. So speed is equal to distance by time. Okay, so time is equal to distance by speed. So d by 10. So T2 is equal to d by 20. So T3 is equal to d by 60. Okay, 60. So T1 plus T2 plus T3 is equal to d by 10 plus d by 20 plus d by 60. So what is the LCM? 60 is the LCM. Okay, 60 upon, that is 6 times, that is 6d plus 3d plus d. So 9d plus d, that is 10d divided by 60. So that's equal to d by 6. D by 6. So VAV is equal to total distance, that is 3d, by total time, that is d by 6. So that's equal to 3d into, okay, 3d into 6 by d. So d get cancelled. So 6 3s are 18 kilometer per hour is the answer. So option C, 18 kilometer per hour. Okay. So fourth question. A car moves a distance of 200 meter. It covers the first half of the distance at speed 40 km per hour and the second half of distance at speed v. The average speed is 48 km per hour. The value of v is. So these are the 4 options given for this question. A 56 km per hour, B 60 km per hour, C 50 km per hour and D 48 km per hour. So a car is moving in the straight line between 2 points, what, P and Q. So the total distance between the 2 points P and Q is 200 meter. So the first half of the distance it moves with 40 km per hour and the second half of the distance it moves with the speed, that is v. So average speed is given, that is 48 km per hour. So we have to find the value of this v. So in this question, that is first half of the distance and again the second half of the distance. So immediately we can write the formula, that is VAV is equal to, that is 2v1 v2 divided by v1 plus v2. Okay, so VAV is given, that is 48. Okay, 48 is equal to 2 into v1, that is 40. So 2 into 40 into v2, that is v, divided by v1 plus v. Okay, v1 plus v. So cross multiply, that is 48 v1 plus 48 v is equal to 80 v. Okay, 80 v. So here so 48 is equal to 2 into 40 into v. v1, what is v1? That is 40 plus v. So cross multiply. So 48 into 40. So 1920 plus 48v is equal to, that is 80v. Okay, 80v. So from this 80v minus 48v. So 32v is equal to 1920. So v is equal to 1920 divided by 32. So cancel with the 8. So 4 times. Okay, 4 times 8. 2 times 16. So 3 balance 32. 4 times then 240. So cancel with 4, that is 6, then 60. So the value of v is equal to 60 kilometer per hour. V is equal to 60 kilometer per hour. So answer is B. Okay, answer is B. Fifth question. A body starts from rest. What is the ratio of the distance travelled by the body during the 4th and 3rd second? So these are the 4 options given for this question. So A is equal to 7 by 3, B is equal B 7 by 5, C 5 by 7 and D 3 by 7. So it is given in the question, a body starts from rest. Okay, starts from rest, that is the initial velocity is equal to 0 and it is moving with the uniform acceleration. Okay, uniform acceleration. So we have to find the ratio of the distance in the 4th second and 3rd second. Okay, 3rd second. So the distance travelled by the object in nth second, yes, nth second is equal to formula u plus a by 2 into 2n minus 1. Okay, 2n minus 1. So yes, 4th. Okay, yes, 4th is equal to, that is initial velocity 0. It is moving with the uniform acceleration, that is a by 2 into 2 4s are 8, 8 minus 1, that is 7. So that's equal to 7a by 2. And yes, third. Okay, yes, third is equal to initial velocity 0, that is a by 2 into 3 2s are 6, 2 into 3 6, 6 minus 1, that is 5. So that's equal to 5a by 2. 5a by 2. Okay. So we have to find the ratio of S 4th divided by S 3rd is equal to, that is 7a by 2 into, that is 2 by 5a. Okay, 2 by 5a. 2 get cancelled, a get cancelled, that's equal to 7 by 5 is the answer. 7 by 5. Option B is the answer. Okay, option B is the answer. So the next question. So the velocity of train increases uniformly from 20 km per hour to 60 km per hour in 4 hours. The distance travelled by the train during this period is. So these are the 4 options given for this question. A 160 km, B 180 km, C 100 km and D 120 km. So the situation is like this, the train, the speed of the train increases from 20 km to 60 km. So the initial velocity of the train is 20 km and the final velocity of the train is 60 km per hour. It takes the time interval or duration for 4 hours for this velocity change. So we have to find the distance travelled by the train. Okay, distance travelled by the train. So first I am using the kinematic equation, V is equal to U plus AT. Okay, V is equal to U plus AT. What is V? V is the final velocity, that is 60 km per hour. What is initial velocity? U is equal to, that is 20 km per hour. Acceleration we have to find out, and time t is equal to, that is 4 hours. Okay, 4 hours. So substitute the values. So 60 is equal to initial velocity, that is 20 plus a into 4. Okay, so 4a is equal to 60 minus 20, that is 40. So a is equal to 40 by 4. Okay, 40 by 4, that is 10. So acceleration of the train is equal to a is equal to 10 kilometer per hour square. Okay, kilometer per hour square. Okay, kilometer per hour square. Next we can find the distance traveled by the train. Okay, I am using the kinematic equation, that is v square minus u square is equal to 2as. So what is the final velocity? That is v is equal to 60 kilometer per hour. What is the initial velocity? U is equal to, that is 20 kilometer per hour. What is the acceleration? A is equal to 10 kilometer per hour square. Okay, so yes, we have to find out. So substitute the value 60 square. So 3600 minus, what is 20 square? That is 400. Okay, 400. 400, that's equal to 2 into, what is the acceleration? That is 10 into s. Okay, s. So 20 s is equal to 3200. Okay, 3200. So s is equal to 3000. So 3200 divided by 20. So cancel. Okay, so 60. Okay, 160 is the answer. Okay, so 160 kilometer. So s is equal to 160 kilometer. Okay, s is equal to 160 kilometer. So this is the answer. So option A is the answer, 160 kilometer. Okay. So the next question, a car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta and comes to rest. If the total time elapsed is t, then the maximum velocity acquired by the car is. So these are the 4 options given for this question. A, alpha square plus beta square divided by alpha beta into t. B, alpha square minus beta square divided by alpha beta into t. Option C, alpha plus beta divided by alpha beta into t. Option D, alpha beta t divided by alpha plus beta. So this is the visualization of the question. A car starts from rest. It is given in the question, a car starts from rest and accelerates with a constant acceleration alpha. Okay, alpha. And after time t1 it reaches the maximum velocity. Okay, maximum velocity. So from that point onwards the car starts to decelerate with a constant deceleration beta. So we know that once the deceleration happens, after a certain distances the car comes to stop. Okay, comes to rest because the velocity decreases. Deceleration happens means velocity decreases. Okay. So in the question it is given the total time elapsed for this motion is, that is t. So I am taking that time, that is first part of the motion. Okay, first part of the motion I am taking t1. So what is the time taken for the second part of the motion? That is t minus t1. Okay, so we have to find this maximum velocity v, we have to find out. So first part of the motion I am considering, that is I am using the kinematic equation v is equal to u plus at. Okay, so v is equal to, what is the initial velocity? 0. What is acceleration? So that is alpha. What is the time taken? That is t1. So v is equal to alpha t1. Okay, so similarly find the second part of the motion. Okay, second part of the motion. So I am using the kinematic equation, that is v is equal to u plus at. So what is final velocity from this point to this point? Okay, the second part of the motion. So what is the final velocity? 0. What is the initial velocity? So initial velocity from this point to this point. So what is the initial velocity? That is v is the initial velocity. For the second part of the motion, v is the initial velocity. Okay, so v minus, so here deceleration, so minus beta, okay, minus beta into what is the time taken, that is t minus t1, okay, t minus t1. So from this minus beta into t minus t1 is equal to minus v. So this minus minus cancel, okay, minus minus cancel. So beta into t minus t1, okay, t minus t1 is equal to, so like this. So what is from this step, what is the value of v, that is alpha t1, that is 0 is equal to alpha t1 minus beta t, minus into minus plus, that is beta t1, okay, beta t1. So t1 take commonly outside, so we will get that is alpha plus beta, okay, alpha plus beta, you bring this minus beta t this side, so we will get that is beta t, okay. So from this t1 is equal to beta divided by alpha plus beta, okay, alpha plus beta into time. So substitute the value of this time t1 in this equation, first equation, so you take it as this equation number 1, okay, equation number 1. So substitute the value of this t1 in the first equation, so v is equal to alpha, what is the value of t1, that is beta divided by alpha plus beta into time, okay. So that is nothing but alpha beta t, so v is equal to alpha beta t divided by alpha plus beta. So option D, that is alpha beta t divided by alpha plus beta is the answer. Okay. So the next question, a particle moves along a straight line such that its displacement at any time t is given by s is equal to t cube minus 6t square plus 3t plus 4 meters. The velocity when the acceleration is 0 is. So these are the 4 options of this question. So A 3 meter per second, B 42 meter per second, C minus 9 meter per second, D minus 15 meter per second. So this is the visualization of the question. So a particle is moving in the straight line. So after time t, let S be the displacement of the particle, okay, displacement of the particle. So the displacement is given by, in terms of t, it is a function, okay, function of time, okay, function of time. So S is equal to t cube minus 6t square plus 3t plus 4 meter. So we have to find the velocity when acceleration is equal to 0. So we have to find the velocity, the value of velocity when the acceleration is equal to 0, okay. So S is equal to, solution, S is equal to t cube minus 6t square plus 3t plus 4, okay. So velocity is equal to ds by dt, okay. So instantaneous velocity, v is equal to ds by dt. So that's equal to d by dt of t cube minus 6t square plus 3t plus 4. So differentiating with respect to time, so 3t square minus 12t plus 3. So this is the velocity, okay, velocity function. So velocity is equal to 3t square minus 12t plus 3, okay. So next we have to find the acceleration. So A is equal to dv by dt. So the rate of change of velocity is known as acceleration, okay. So A is equal to dv by dt. So that's equal to d by dt of, what is v, that is 3t square minus 12t plus 3. So that's a differentiating with respect to time, that is 6t minus 12. Okay, 12. So this is acceleration. So we have to find the velocity when acceleration is equal to 0. So when acceleration is equal to 0, that is 6t minus 12 is equal to 0. So 6t is equal to 12. So t is equal to 12 by 6. Okay, 12 by 6. That is t is equal to 2 seconds. At the time t is equal to 2 seconds, the acceleration becomes 0. Okay, acceleration becomes 0. So at that time, what is the velocity? So when time t is equal to 2 seconds, we have to find the velocity. Okay, velocity. So how to find at the time t is equal to 2 seconds. What is the velocity? So v is equal to, substitute the value of time, that is 3 into 2 square, that is 4, minus 12 into 2 plus 3. So that is 12 minus 24 plus 3. Okay, 12 minus 24 plus 3. So 12 minus 24, that is minus 12. Okay, minus 12 plus 3, that's equal to minus 9 meter per second. Okay, minus 9 meter per second. So minus 9 meter per second. So compare the option, that is 3 meter per second, 42 meter per second, and minus 9 meter per second. That is the answer. So displacement is given in terms of time. So we have to differentiate. First we have to differentiate one, so we will get the velocity. So again differentiate the velocity, we will get the acceleration. So condition is given in the question, that is when acceleration is equal to 0. So apply that condition, when acceleration is equal to 0, find the value of time. So substitute that value of time in velocity, you will get the answer. So minus 9 meter per second. Okay. So the next question. The acceleration of a particle is increasing linearly with time t as bt. The particle starts from origin with initial velocity v0. The distance travelled by the particle in time t will be. So these are the 4 options given for this question. Okay, that is v0 t plus 1 by 3 bt square. Option B, v0 t plus half bt square. Option C, v0 t plus 1 by 6 bt cube. Option D, v0 t plus 1 by 3 bt cube. Okay, 1 by 3 bt cube. So this is the visualization of the question. So an particle starts from the origin and it is moving with the acceleration. Okay, so the acceleration is increasing, or acceleration increasing linearly with the time. So it is given by the equation A is equal to bt. Okay, so the particle starts from the origin with the initial velocity v0. So after time t, let s be the distance travelled by the object. So we have to find this distance. Okay, so understand the question. A particle starts from the origin with the initial velocity v0 and it is accelerated. Okay, accelerated linearly with the time. So it is given by the equation A is equal to bt. So after time t, let s be the distance travelled by the object. Okay, object. So we have to find this distance. So what is given, that is acceleration is given, A is equal to bt. So from this point we are starting. Okay, so acceleration, so we can write that is dv by dt. So that's equal to bt. Okay, so dv is equal to bt into dt. Okay, bt into dt. So integrating on both sides. So integration of dv is equal to integration of bt dt. So what is integration of dv? That is v is equal to, So b is a constant, so b, what is t dt integration, that is x dx, so t square by 2 plus one constant of integration, okay, one constant of integration. So applying the initial condition given in the question, we can find the value of this constant. So what is given at a time t is equal to 0, at a time t is equal to 0, what is the velocity? v0 is the velocity. So apply this condition in this equation. So v0 is equal to, when time t is equal to 0, you write like this, that is when t is equal to 0, v is equal to v0. So apply this condition. So v0 is equal to, so apply the, that is substitute the value for time is 0, so this time becomes 0, so that's equal to constant. So the constant of integration, the value of constant of integration is c is equal to v0. Okay, so substitute the value, that is v is equal to bt square divided by 2 plus constant of integration, that is v0. Okay, so this is the velocity. Okay, this is the velocity, but we have to find the distance traveled by the object. Okay, so this v we can write, that is ds by dt. Okay, ds by dt is equal to bt square by 2 plus v0. Okay, v0. So separate the variables, that is ds equal to bt square by 2 plus v0 into dt. Okay, dt. So integrating, again integrating on both sides. Okay, so integral of ds equal to integral of bt square by 2 into dt plus integration of v0 dt. Okay, v0 dt. So the distance changes from, when time, this time changes from 0 to t. Okay, so the time changes from 0 to t. So here also the limit is 0 to t. So when the time changes from 0 to t, the distance changes from 0 to s. So here the limit is 0 to s. Okay, so ds, integration of ds, that is s. So apply the limit s minus 0, that is s, is equal to, so b t square b t cube divided by 6. So the limit is 0 to t plus v0 is constant, dt, that is t. So the limit is, that is 0 to t. Okay, so apply the limit. So s is equal to b t cube by 6. So apply the lower limit 0. So plus v0 t. Okay, so s is equal to bt cube by 6 plus v0 to t. So this is the distance traveled by the object in time t. So compare the option, that is so this option C, that is v0 t is there, then 1 by 6, this 1 by 6 bt cube. Okay, bt cube. So option C is the correct answer. Option C is the correct answer. Okay. So the 10th question. If a car at rest accelerates uniformly to a speed of 144 km per hour in 20 seconds, it covers a distance of. So these are the four options, that is A 1440 centimeter, B 2980 centimeter, C 20 meter and 400 meter. So it is the visualization of the question. A car starts from rest, it is given in the question. So initial velocity is 0 and accelerated uniformly. Okay, accelerated uniformly. So the acceleration is not given. So I am taking the acceleration A, and it reaches the accelerates uniformly and reaches the velocity, that is v is equal to 144 km per hour. Okay, per hour. So v is equal to 144 into 5 by 18. Okay, 5 by 18, that is meter per second. So 2 times 2 So 16. Okay, 16. 16. So 2 8 times. So 8 5s are, that is 40. Okay, so 40 meter per second or 40 meter per second. Okay, 40 meter per second. So it covers a distance of s meter in time t is equal to 20 seconds. Okay, t is equal to 20 seconds. So the distance covered by the object we have to find out. So how much distance it covers. So I am using the kinematic equation, that is v is equal to u plus at. Okay, so what is the final velocity, that is 40 is equal to, so substitute the values. So v is equal to 40 meter per second. What is the initial velocity? U is equal to 0. Acceleration we have to find out. Time is equal to 20 seconds. Okay, so substitute the values. So 40 is equal to 0 plus a, that is acceleration into in time, that is 20 seconds. So a is equal to 40 by 20. So 2. So a is equal to 2 meter per second square. So that is the acceleration. Okay, that is the acceleration. Okay, so the distance traveled by the object we have to find. So v square minus u square is equal to 2as. Okay, 2as. What is the final velocity? V is equal to, that is 40 meter per second. Okay, 40 meter per second. What is the initial velocity? 0. Acceleration is equal to 2 meter per second square. Yes, we have to find out. Okay, substitute the values, that is 40 1600 minus 0 is equal to 2 into a, that is acceleration, that is 2 into s. Okay, so 4s is equal to 1600. So s is equal to 1600 divided by 4. So 4 times. So s is equal to, that is 400 meter. That is the answer. So option D is the answer. Okay, so with this I conclude this session. So totally 10 problems we have solved from the Neet session. So next time I will come with another 10 problems of previous year Neet questions. So until then, stay tuned. So once again wish you all the best for all the Neet aspirants across the country. Thank you.